Hello everyone, it's Mrs Jennison here again. I'm one of the Associate Directors for Outward Grange Academy's Trust. And in today's lesson, we will be looking at identifying common gases. As with all of our lessons, it would be really useful if you had a pen or a pencil and a piece of paper so that you can work through the activities with us in the video. Our challenge for today is to be able to describe the tests which can be used to identify certain gases. Our aspire is to be able to explain the importance of gas tests. So, first task. I would like you to look at the images on the screen. Can you, by looking at these images, identify the gases in each of those situations? There's a good chance you are looking at the video now going, how are we supposed to do that? Well, you're not. That's kind of the whole point of that question. All of these gases are colourless, and without me telling you the chemicals involved in that reaction, for example in the middle image, magnesium and acid would let us know that that gas is hydrogen, we would have no way of knowing without testing that gas which exact gas it is that's being formed, which is kind of the point of today's lesson. Gases are really hard to identify, and this is mainly because the gases are colourless. However, it's really important that we can identify these gases for a number of reasons. The first one being this can help us figure out what kind of reaction is occurring. And the second one being that these gases have very different properties. Now, there are 4 gases that we need to be able to test for on our specification. I'm going to go through each of these gases and the tests individually. So the first gas we are going to look at today is hydrogen. Hydrogen is a flammable gas, and you can't expose the hydrogen to open flames. This actually was the cause of a famous disaster called the Hindenburg disaster. And I'm going to insert that video for a little bit of context before I show you how we test for hydrogen.
Nearing the fatal end of her first Atlantic trip of the season, the Hindenburg approaches the mooring mast at Lakehurst. 21 of these sky voyages the world's biggest dirigible has made, so safely, so surely that the experimental service has become a matter of routine. Scarcely 100 feet above ground, the giant airship with her framework encasing 7 million cubic feet of inflammable gas is being carefully maneuvered towards her hangar, when suddenly appalling tragedy is a matter of seconds. It seems almost incredible that anyone should escape, yet 2/3 of those on board survive what is, next to the R-101 disaster, the worst in the history of aviation.
So it's that explosive property of hydrogen that we actually utilise when testing for that gas. The first thing is obviously to collect the sample of the gas. Now, in testing for hydrogen, we then also need a lip splint, and we place that lip splint into the test tube containing the gas. And what we hear is, as a result of that test, is a popping sound, but you can also see a very small explosion inside of that test tube, as you'll see on the next slide. Now, this has frequently been called the squeaky pot test, but better practice in exams, if you are asked to describe this test, is to describe how you would carry it out. And then the result of this test is the popping sound. Moving on to our next gas, chlorine. You may remember us mentioning this gas when we learned about water and sterilising water. Now, the reason we can use chlorine to sterilise water is because it is actually a toxic gas, which means it's really important that we know how to test for this. Now, in testing for chlorine, again, the first thing we will need to do is collect a sample of that gas. Now, this time we will place damp litmus paper into that sample. It can be either colour litmus paper, and the next video I'll show you uses both colours so you can see the difference. Now, the chlorine reacts with that and actually bleaches the colour from the litmus paper. As you can see here, both red and blue damp litmus paper were held into the chlorine, and you can see them both losing their colours quite quickly. If you look on the blue one, you can actually see it turn red first and then get bleached. The next gas for us to look at is oxygen. Oxygen obviously being a really important gas for us, but we have mentioned it when we looked at the fire triangle earlier on in school. Oxygen is one of the 3 things required for fire, and it's that property that we can use to test for oxygen gas. Now, this is similar to the hydrogen test, but there's a few very important differences. So again, we'll collect our sample. But this time we will place a glowing splint into the sample, not a lit splint. It's like when you just blow out a candle and you see that little glow on the end of the wick, that's what you want to place into the gas. What actually happens is that splint then relights, and it looks fabulous when you look at it. So I'll just show you the video on the next. So here you can see the small glow on the end, and when it's placed into the oxygen, the splint completely relights. The final gas we need to know how to test for is carbon dioxide. Now, we've learned about carbon dioxide when we learned about pollutants and global warming, and that's the effect of that on our planet. Testing for carbon dioxide is slightly different. What we actually have to do is we have to get a substance called lime water. It's calcium hydroxide solution, but it's typically known as lime water, and that reacts with carbon dioxide. So what we do is we bubble that gas through that lime water, and the lime water turns cloudy. It's actually making a white precipitate within the water, which is what causes that cloudiness. But we need to make sure that we mention that it's going cloudy. Now you can see this again on the next video. So the test tube on the left with the green powder in, which is turning black, is copper carbonate, and it's giving off carbon dioxide, which is being bubbled into the test tube on the right. And you can see the colour change occurring in that right test tube. That's your lime water. So that's turning cloudy, which shows us that the gas being given off is carbon dioxide. Now that we've gone through all of those tests, I would like you to have a go at answering the questions on the screen. First of all, explain why it's hard to identify gases. Then I'd like you to describe the tests and give the results for all of those 4 gases. So hydrogen, chlorine, oxygen, and then carbon dioxide. Let's check our answers. For the first one, they're all colourless gases. To test for hydrogen, you place a lit splint into the test tube and you will hear a popping sound. To test for chlorine, you add damp litmus and it will bleach. To test for oxygen, you place a glowing splint into the oxygen and it will relight. And to test for carbon dioxide, we'll bubble the gas through lime water and it will turn cloudy. So let's summarise these gas tests before we start some exam questions. First of all, oxygen. The test is to insert a glowing splint and the splint will relight. Hydrogen. The test is to insert a lit splint and you will hear a popping sound. For carbon dioxide, the test is to bubble the gas through lime water and the lime water will turn cloudy. And for chlorine, the test is to insert damp litmus paper and the litmus paper will be bleached. Now I think it's time for us to have some exam questions. I've picked quite a few this time as these normally come up as a part of another question on another topic. So they're normally linked to a reaction that causes one of these gases. So let's read through the first one. Carbon dioxide is produced when metal carbonates are heated. They'd like you to choose the correct answer to complete the word equation. Magnesium carbonate makes blank and carbon dioxide. And then choose the correct answer to complete the sentence. The reaction to produce carbon dioxide from magnesium carbonate is, and then choose the correct word. The next one. So, a student investigated what happens when metal carbonates are heated. The student used the apparatus to investigate heating for metal carbonates, started the stop clock at the same time as he began to heat the metal carbonate, stopped the stop clock when carbon dioxide was produced. The student's results are shown in the table. So we've got the metal carbonate and the time taken for the production of carbon dioxide to start. First question on this, which type of graph would the student draw from those results? Okay, so the next one, how did the student know that carbon dioxide was produced? They want you to use the diagram from earlier, so I've re-included it on the side for you. So the next one, question 2. Hydrogen peroxide is often used as a bleach. It decomposes, forming water and oxygen. Give a test for oxygen, and you've been asked for the test and the result of that test. Bleach is a solution of sodium hypochlorite. Chlorine gas is produced when bleach reacts with hydrochloric acid. Give the test and the result for chlorine gas.